Okay, so what we're going to do tomorrow is, it's going to be hard work tomorrow. It's going to be bell to bell. But we have to understand this new notation to do some of the things we're doing tomorrow. So we're introducing it today. It shouldn't take us very long. And then you have time to work on your assignment. And I can put up some of the problems that are right out of the book. I can put them up on the smart board. Okay, so this has nothing to do with what we did yesterday, but sometimes we have to add up numbers. And we're going to add up the numbers 1 to 100. Oh, might be able to do it. Okay, that works. Okay, so we're going to add up numbers 1 to 100, and you could write them 1 plus 2 plus 3, 100. Now that takes a little bit of time to do, and just as in the old, when we did algebra, we added x plus x plus x, and we didn't want to write that out like that. We made up a notation and we called it 3x. So if you have 3 plus 3 plus 3, that's where multiplication came from. I said, I don't want to write 3 up there 3 times, so it's 3 times 3. And that's how that all got invented. So some people were adding things up, and that's probably the Greeks, because it's a sigma notation. And they said, I want to be able to write the numbers from 1 to 100, but I don't want to write them all out. I got to invent a notation that means to add them all up. And sigma actually comes from the Greek. It looks like this, and it's spelled sigma. And it is like the S. It's the S in the Greek alphabet, which means to sum. Well, then that makes me think of Gauss. Now, the last class didn't know who Gauss was. You know who Gauss is? Nobody in physics? He's a very famous physicist. And he was absolutely brilliant. But he was also very naughty. So in first grade, I believe it was first grade, it could be spreading tales about Gauss. Do you know about Gauss? Gauss. Gaussian elimination? Gauss. He's a famous physicist. Yes? Uh-oh. Okay, so Gauss was in first grade. He's very naughty, and his teacher wanted him just to behave himself and get out of her hair. So we sent him to the corner of the room, and it says, I want you to add up the numbers 1 to 100, figuring that would take him a little bit of time. Well, this is what he did. He goes 1 plus 100, and then he goes 2 plus 99, and then he goes 3 plus 98. What are these all adding up to? 101, and how many of them are there? Well, there's 50 of them, right? So he says, well, it's 50 times 101. Whoops. He was brilliant. And if Mrs. Hersman wants to stay a little bit longer, I can show her how we do this on a calculator. If she hasn't seen that. It's kind of cool. Oh, okay. So we made up the sigma notation. So anyway, he multiplied these out. And he got back in trouble again. He was naughty again. So I don't know what the teacher did after that. Probably turned gray. So the notation is this Greek letter sigma, and it has a counter. And these counters are whole numbers. They're not even integers. They're not negative. They're positive whole numbers. They increase by 1. So we start with, and usually we use I, J, and K as an index. It's called the index. I is going to start with 1, and I'm going to go up to 100. And then it's just going to be I. And that just means 1 plus 2, we're just going to do the calculator, anyway, plus 3 plus, now, we have it, if you have the new operating system on your calculator, you can put that on your calculator and get an answer. Now, generally speaking, nobody's going to ask you to do anything like that. They're not going to ask you that at the exam. It'll be a finite number, like 3, not 100. But let's use the calculator because I think it's kind of interesting. So if they got to find it, just have to bring it up. Anybody in here have the new operating system? If you have an 84, you want the new operating system. Don't have it on the 83. Sorry. But it's kind of nice to see that. Now, if I were going to get a new calculator, I'd probably get the cast one. The cast Inspire, because it does everything. It does all of this besides. But if I want to go alpha, window, I can get sigma right there. And look at that, it has the index. So I'm going to start with I. Now, it's already set in alpha mode. Last class wanted me to put in X. I said, no, I'm putting in I. 1, then I'm going to go up to 100. And then I'm just showing you sigma. This little thing we have right here, the calculator will do it for us. And it's going to do I. Oops, I've got to take alpha, I. Then press enter. And it gives you the answer. So it's kind of cool. No, you can't. You got to have an 84. You don't have an 84. It's got to be an 84. You have an 83. 83s can't do it. I wish they'd fix the operating system so that you could do it with an 83. You can't. So, as far as you're concerned, you just need to know what the notation is. And there are formulas for these things, and we'll look a little bit at that, maybe a little bit tomorrow. That's why, well, I don't know, we may do trapezoidals now that we're looking at things. Okay, so what does this mean? What's the first number you're going to put into this? This is what we're going to do. Summation I equals 1 to 100, and it's going to be the square of it. Yes, you could find out what it is. I don't know what it is. But what does it mean? It means, what's the first number I'm going to put into that little formula? 1 squared, and then I'm going to increment by 1. So I'm going to get up to 2 squared, and increment by 1. 3 squared, and you keep going. And on the exam, they might say write out the first 3 terms. We do a lot of this in BC Calc. We do a ton of this in BC Calc. And that's all that means. So it's just a shorthand notation of writing up the squares from 1 to 100. That's all. And then you have programs, of course, that can calculate these things. And there's formulas, but we're not going to do that today. So let's write out what the next ones mean. So this should not be terribly difficult. It should be actually a little bit of breathing space from the hard stuff that we've been doing. What are we going to start with on this one? Brief, what am I going to start with on this one? B sub what? 2. And then I'm going to do plus B sub 3. Yeah, this isn't hard, is it? Plus B sub 4. Plus B sub 5. That's it. That's all there is. So the homework, there's like 10 little problems like this. It's not too bad. What does this one mean? Now it's a little different. It doesn't have a little subscript there. So this is a constant. So it's going to take B, and it's going to start with I equals 2. And then it's going to let I go to 3. It's just a counter. And I'm going to add B again. And I'm going to keep adding B until I get to 5. So I equals 4. So it's plus B. And then I equals 5 plus B. And of course, we can write that much simpler as, what is it? 4B. That's all there is. So it's just a matter of getting used to a new notation. We do a lot of it next year in BC Calc. You could see it, it's possible to see it at SAT, ACT. Have you seen it on there? No? Surprise, actually. Okay. We have properties of sigma. Guess what? They're the same as our properties for derivatives. This first one is saying I'm going to add up C n times. So I is equal to 1, I'm going to add up C. And then when I is 2, I'm going to add another C. And then when I is 3, I'll add another C until I do this n times. Well, that's just multiplication, n times C. That's what multiplication is, repeated addition. I haven't thought of multiplication that way. This says you can distribute over a sum. You can do the sigma of A sub I and the sigma of B sub I. Same thing with the subtraction, so it's not any different. So it's just like the fact that you had an integral of 2 functions, derivative of 2 functions, you can distribute the derivative. And what this one's saying over here is that you can pull the C out in front, just like you can take a constant through the derivative operator. So there's nothing new about this. It is related. And then we are going to skip the collapsing sums. They're not that hard. They're kind of interesting. We'll do that next year. Those of you who take BC. Okay, so how can I do this? I could distribute that, or I could just substitute it in. It doesn't really matter. Last class, I just substituted it in. So what does this mean? And we're not going to even simplify because I don't really care. When I is equal to 1, it's going to be 2 times 1, and then it's going to be 1 minus 5. You're only doing 10. That's not too bad. You could put it on your 84 calculator, by the way, because it'll do it. You just have to type in that little formula. And then what's the next I value? 2. So it's plus 2 times 2, and then it's 2 minus 5. And what's the next one after that? What's the next one after that? It's 3. So it's plus 2 times 3, and 3 minus 5. And the last one, I'll put it in there. You could evaluate it. There's little formulas, too, that you could do. And the last one is going to be 2 times 10, and then 10 minus 5, right? I write it out because I won't know what it is. But I mean, you could see patterns probably. Well, I don't, you can multiply it out. This is 2 times negative 3, negative 4. And this is plus 2 times negative 3, plus, this is, 4. I was just thinking of factoring that 2 out. Sorry, 4 times negative 3. What's the next one? Plus 6 times negative 2. You just have to multiply it out. It's not hard. And the last one is going to be 20 times 5. Okay, so it's arithmetic. And you don't want to do it either, do you? I don't either. I'm not going to do it. Okay, how about the next one? Can you write that in sigma? Now, the counters are usually I, J, S. You can just multiply it out. It's just arithmetic. Okay. Or you could just leave it. I don't care. The point is to understand what sigma is. What counter would you like to use? I, J, or K? I. So what's I going to start with here? 1. Sometimes it doesn't. Usually you want them to start with 1 or 0. And what's the maximum we're going to go up to? 70. It's easy, isn't it? And what's this over here? What's my rule? 1 over I. That's all there is. It's hard to read that. Yeah. And then the next one, we're just going to use properties of sigma to figure out what this last one is. And the sigma is going on this whole thing, so I probably should have had parentheses there. It would have been a little bit better, but I didn't. So I'm going to have sigma, and we're going to use our properties to figure out what this sum is. So I will get an answer for this one. I equals 1 to 10. And then it's this. And we can distribute over addition, subtraction. Can't distribute over multiplication. It doesn't work. Okay, so we're going to go ahead and distribute that. I'm going to do one step at a time. So I'm going to do sigma of the first term, and then the second term, and then the third term. So this is sigma for a sub I, and I is equal to 1 to 10. And then you're going to distribute that to the b's. So it's minus sigma, and it's pain. Next year you're going to be lazy about this. You don't want to write it out, but we have to. It's p sub I. And then you're going to distribute the sigma to the 2. That's usually where the mistake is, forgetting about the 2. Because you don't like the constants. Is that okay? And then can we pull that 4 out of there? Yeah, we can pull 4 right out of there. Put it right out in front, like that. So I'm going to do that. And then we're going to use the information they gave us to figure out what this is. I'm just doing one step at a time, so I'm just not going to do anything with those last ones yet. But I'm not going to not write it down, because if I don't write it down and try just in my head, I'm going to make a mistake. You can make a mistake without that. this one. And they gave us some stuff here, didn't they? They told us what the summation of a sub I was from 1 to 10. I don't know what the formula is, but I just know what it adds up to. What's it add up to? 40. So this is 4 times 40. And then minus the summation of b sub I, which I have no idea what that is. That was 50. Yeah. So this is going to be kind of nice because it's not too tough to do. Plus 2. How many 2's are going to add up though? So it goes from 1 to 10, so it's times 10. Because that means 2 plus 2 10 times. So that's going to give you a 20. That's the hardest one. Because you're going to add up 2 10 times. I'm going to keep giving you $2. And then the rest is arithmetic. We should be able to do this without a calculator. 160 minus 50 plus 20. Be careful with order of operations. I'll just go left to right, and then I don't have to worry about it. That was the summation of b sub I. This one. And so that's 110 plus 20, which is 130. And that's all there is. So the problems on the quick review are pretty easy, but most people got those done without a problem. There's one last problem that you don't have to do, but we'll go ahead and do it just to show you an idea here. And it says, I want to change the variable, and there's a typo on here, unfortunately. Kind of major, actually. This is k equal to 5. So if you were to write out what this is in a sum. Oh, yours says, okay, mine's got the typo. Let's fix it someplace. So I'm going to start with 5. So it's 5 times 2 to the 5 minus 4. That's what that is. Plus, and then what's the next number going to be? 6 times 2 to 6 minus 4. And the last one's going to be 14 times 2 to the 14 minus 4. And what we can do is rewrite this so that we have, we start with 1. Usually we want to start with 1, so this is just a matter of kind of practicing to start with 1. So I'm going to change my index, but use a different letter. What letter would you like to use? I. So I want to start with 1. Now, how do I get that? What am I going to do with k? We'll subtract what? I is equal to the k value. I'm shifting it down 4. So what's going to happen to the top number? If we're at 14, you're going to go down 4, so you're going to be at 10. And then I have a little formula here. What's k equal to? Solving this for k, I get what? I plus 4. And that's all I have to do is put that right in there for k. So it's I plus 4. And then it's 2 to the k minus 4, which is I plus 4 minus 4. So the 4's are going to go away. Now, do you believe they're the same? Let's find out. It's just a shift. That's all it is. Let's let I equal 1 and put that in here. I get 1 plus 4 times 2 to the 1. Is that what I have over here? Yeah. Plus, sorry, I ran out of space here. And then I'm going to let I become 2. So it's going to be 6 times 2 squared. That's the same as that. Let's check the end. Let's do 10 plus. If I put 10 in there, I'm going to get 14 times 2 to the 10th. And that matches as well. It's just shifting the index. We will not be testing you on it. You wanted to know that. Sometimes in the BC Calc, we go from 0 and we shift to 1. But it just kind of happens naturally. Everybody simply just adapt to it. I don't even take time to teach it. They just figure it out. And that's all there is. So the rest of the time is for you guys to work. And I will put up on the smartboard pictures of some of the problems if you don't have your book. But I do have an extra book here too. Make sure to bring your book. We're also going to start giving you some AP practices. Now you know enough to do the AP problems that relate to these. There will be one on the exam that have these Riemanns on.